Let's commence the last lesson of this unit. Keeping in mind that tomorrow, so this is our last lesson of the unit tonight. You'll be doing the last homework 8, which includes the worksheet. I'll make sure you get it. Thanks, guys. Tomorrow we have like kind of a practice cleanup / game day. Yeah, we're gonna play a little game. Friday we have IB problem. Monday is like a review day maybe, and then Tuesday is the test, right? So this is up here, the calendar that I gave you earlier on. Still true. Everything's okay. All right. So area, we're going to talk about area of 3 different things today. We're going to talk about how to find the area of a triangle, how to find the area of something called a sector, and how to find the area of something called a segment, and maybe some applications of those things too, if we can do it. The area of a triangle, you say? I know how to find the area of a triangle. It's 1/2 base times height. All right, well, here's a new formula for you, right? I actually have 2 formulas for the area of a triangle for you today that you haven't seen before, and you're going to like them, okay? So this one's useful, right? Because it's not always true that someone, like, hands you the base and hands you the height of a triangle. If they do, then, like, yay. But if they don't, then, like, you have, like, maybe some work to do. So this is very convenient. This particular formula is very convenient. If someone hands you 2 sides and the angle between them, that defines a unique triangle, doesn't it? And that's how you find the area. Now, I won't prove everything we're going to show you today, but the proof of this is pretty intuitive. Here's some triangle. Call it A, B, C, with side lengths B, side length C, side length A. And let's go with old school here. I want to think about the height. Old school, you'd be like area, and by A I mean area here. Sorry, A is confusing for area. I'll write the word area here. Area equals 1/2 base times height, I hear you say. Yes, right? Conveniently, I went out of my way to make this convenient. Do you like that? B means this side length. It also means base, though. You like how I did that for you? Okay, you're welcome. Okay, so that was convenient of me. And then I've also labeled H. So if someone gave you B and H is at a right angle to the base, the altitude there, you'd be like, sweet, I have B, I have H, let's go. But if someone gave you side A, just to keep consistent with this formula here, someone gave you this little side A here, and you also knew this angle, C, could you compute H if you didn't know it? If you knew this side length B, this side length A, and this angle, how would you compute the height? Well, we've had this conversation already once or twice in this unit. How do you compute that height? We have like a little right triangle. Yeah, hear the word sine, right? Yeah, it's A sine C, isn't it? It's this side length times the sine of the angle gives you the height here, right? Just using a little right triangle trick. Ignore the rest over here. And just look at this right triangle. The height could be expressed if you knew little a, and big C, it could be expressed as A sine C. Then, make the substitution and call it a day, right? So this formula is as is, even though you're like, sweet, a new cool formula, it works for you. It is actually just 1/2 base times height still, isn't it? So that's the proof off to the side. Substitute for H, and you'll have it. This also comes with 2 other formulas as well that I didn't write down. Another one is the area of a triangle is equal to 1/2 BC sine A, right? Or 1/2 AC sine B. Right? I didn't write them down. You can do that. All right, Peter. Yeah. So that's what I was just saying. You can use. There's nothing special about my labeling here. This works coming from any angle. Let me supply you with one more formula. This one is a challenge to prove. I don't know if I could reproduce the proof off the top of my head. This is called Heron's formula. The first one is cool, but not cool enough to have a name, I guess. The second one is named for Heron, who I don't know whether he actually discovered it or not. All right, so let's process what this says, because it's got kind of an elegant look to it. But first of all, this is useful, like it says up here, when all 3 sides are known. And maybe you've never even thought, maybe I should have posed that question first. Say I give you 3 sides of a legitimate triangle. Can you find the area? I mean, that seems like such a, obviously my 3 sides define the triangle, so I should be able to find the area of that triangle. But like maybe you don't have the equipment in your life to do that. You would maybe have to find an angle and find the height. I mean, you could do that, right? You could go there and you're welcome to do that. But this is kind of elegant. This has no reference to any angles in it. Do you see what S is? I've given you a chance to write this down maybe now, but have you figured out what S is? It says S equals the semi-perimeter, which means half the perimeter, right? So, or if you wanted to write it out, it's 1/2 times the quantity A plus B plus C. Okay, so, and then it might even take a little bit of work to convince you that each of these things in these sets of parentheses are positive even. Is that obvious? I mean, I have to actually kind of think about that a little bit. That half the perimeter minus each side, any given side, will come out to be positive. Yeah, I think we can reason. We'd have to like maybe bring in the triangle inequality though, right? Yeah, that would just be a line. Yeah, exactly. I think we actually have to invoke the triangle inequality in order to prove that that's even true. But yeah, so these things in parentheses will always be positive. This always will work. And now that you have these 2 formulas in boxes, I want you to just give this a try here. Here are 2 triangles with information that's a little bit more non-traditional than you've been handed maybe in a geometry class. So we're going to find the area of these 2 triangles, and please do so without a calculator on both of these.
Why?
Well, because I asked them to.
How do we calculate? I can't go.
Do you not know the sign of
I provide you with convenient values here to make this calculator non-calculator.
Hey, I got it.
Just to show that you know you can do it.
You're not supposed to use it.
Yes, you can do it without a calculator. Yeah, theoretically it's like, speed tree please, go. What's sine of 120? Oh, we should know that. Sine of 253. Root 3 over 2. Do you just know that? Right? Same as the sine of 60 degrees, right? Sine of 60 degrees and sine of its supplement. Sine of 60 degrees and sine of its supplement are the same. Aren't they? Sine of any angle and its supplement are the same. Because they're the same height up the x-axis. Have we thought about this? Okay. So yeah, it's root 3 over 2. Good job. And computing the area we get without a calculator. 15 root 2, root 3. Units squared. Yeah, sure. All right, and then over here, have you done that one yet? Are you working on it still?
Can I just leave it like that?
If it's not a nice quarter square, you can leave it like that. The second one is kind of set up perfectly for Heron's maybe, right? It's not required to use that, but and I've even, like I said, I've even made the numbers somewhat nice. How's it going?
Multiply all that. Okay, 8 times 5 is 40.
No, you're doing 10. 15 times 8 is 100. Plus that's 10.
Is that what that comes out to?
Okay, I'm gonna use a calculator because this is not hard.
15 times 10 is 150. 150 times 8 is 240.
Okay, that's 1200.
All right. Come to order, whether you're done or not with that second one. I think most people have gotten a good crack at it, at least. Okay? So, yeah, so if I'm thinking out loud about this without a calculator, thanks, guys. If I'm thinking out loud about this without a calculator, I might be like, okay, we've got 5 squared under here, don't we? Do you see it? Do you see 5 squared under here? Do you see a 4 squared too? So I think we have, and then the only thing left is a 3. So I think we can write down 20 root 3. You like that? If you wrote square root of 1200, that's also fine. Okay. Either one is fine answer. Okay. I don't want to have to multiply this. I'd rather just like think about the perfect squares maybe and deal with it that way, right? I don't know. Either answer is fine though. Just one is a little computationally easier maybe. Next problem. Ready to go. Next slide. I gotta let you try this with your table. Try this as a group first, and then we'll talk. You need to maybe remember what a pentagon is. And you need to remember what regular means. And you need to remember what inscribed means.
Stats are on 6. Okay, hold on. Wait. Which are this? Wait.
No, the circle's inside it.
No, inscribe it.
Oh, inscribe it.
Well, they're like, we have buildings 3 inches and 3 and 3, that's 45.
Yes.
So we've got calculate it.
It's 180 times 3. It's 540. So yeah, that's
108. Okay, that's right. 108, so 4.
It's all good. Yeah, you might need a calculator for this to give any meaningful answer. Oh, that's not very good. I gotta try again. I don't know, something like that. That's still not perfect.
Oh, that's what it looks like. I drew a house.
It's like part of math teacher training when you're learning to draw regular shapes.
Yeah, drawing is important. That's for sure.
That's why I'm hurting it.
Do you know how to construct ruler, straight edge, compass, pentagon?
Mine looks like a house. It looks like a box of triangles.
Super tricky.
It's 45, 45.
No, it's not.
All right, what's the approach, people out there, as you're working? What are you doing? You drew this picture, and then your observation is that, hey, I can find, maybe not the area of the pentagon immediately, but maybe I can find the area of one of the triangles. Though I still have need of a little more information. What information would be helpful? Yeah, the central, this angle here. Did you come up with it? Yeah, and maybe you just know that you could just divide 360 by 5, or maybe you just know off the top of your head because you're like a pentagon master that has 72 degrees. Okay. The interior angles of pentagon are 108, just like because I happen to know that, right? Maybe you just know that. And then the area of the triangle is They'll be back with me in a second, I promise.
Oh, I can just turn it into 2 triangles. Oh, I can use the area for that.
Alright, let's see here. I need
Is the answer 21 seconds?
Alright, let's
Yes!
Okay, yes. Calm down. Calm down. I'm gonna leave this slide now. Are you Hey guys, thanks. Are you good on this problem? Is there anything more to say about it?
I got it right.
Alright. So we can actually solve other interesting problems in life, right, using some of these formulas too. Alright, let's introduce now formulas to help you solve for the area of a sector and for a segment. We're going to introduce what those terms mean. Thanks for stopping the chatter. Okay, thanks. Alright, first of all, what is a sector? We mean this pie-shaped region. Slice, like it's like a slice of pie, right? We mean a sector of a circle. I think sector is a word that you might know from geometry, so maybe that's not new. If r is the radius of said circle and theta is this central angle, then the area of that sector that's shaded in blue is given by the formula in this box. And maybe exercise for the reader, prove that this is true. Now, I will say this, and this is maybe even hint at a proof. Theta is, as many other formulas in this unit, is in radians. We need to be careful about that when we use this formula. Theta needs to be in radians. That being said, if theta happens to be, I don't know, say 2 pi radians. Let's say I want a really big piece of pie, like aka the whole pie. Okay. What if I want 2 pi radians? Tell me what happens when theta in this formula is 2 pi with 1/2 r squared times 2 pi. Yeah, we just get pi r squared. And then I hear you say pi r not squared. Pi r round. Cornbread is squared. I had some bad news, sorry. Oh my god!
I thought it was a joke.
Yeah, we've had enough for today. Alright, I don't have anything else to say about that formula. Lisa, yeah. All right, here's. Sorry, it's my fault. It's my fault. That was my fault. You got it. Off the rails. That's completely my fault. I'll take credit for that. Let me define for you first. Let me define. Sorry. Let me define for you what a segment is first. Okay, done. It's this thing. The area in a circle cut off by a chord. Okay. Or you could think about the shaded region here. So that's what we mean by segment. The other way you could describe it maybe will give away a way to find this area. Though I don't think I need to supply it with the area formula. How would you find the area of that?
Find the area of the sector minus.
Yeah, area of sector minus area of triangle, and actually, I hesitate to put up a formula here because that's maybe better. You should just go with that. But that being said, it is actually somewhat elegant. All right, calm down. All right, so yeah, it's two different things here. It is somewhat elegant, and I included both simplifications. I included all of it in the box because, like I said, I think it's helpful to realize that it's area of sector minus area of triangle. And is that what those are? Is this a formula I've seen before? Oh, yeah, that's area of sector. It's just right up above here on the slide. Okay, I got you, Mr. Chase. What about this, though? 1/2 r squared sine theta. Oh, yeah, that is the area of a triangle from the first slide today, where we have 1/2 times side, but they're both r, times sine of the included angle, which is theta. And then it just so happens that something factors out nicely. But again, even though that does come out pretty nicely, it looks pretty nice. 1/2 r squared times theta minus sine. I like it. I still maybe would hesitate to memorize that. I'd probably rather just know that it's sector minus triangle. Whatever. You do what you like. As long as you know how to find the area of segment, you and me will be good. Okay? So, like I said, you should know what a sector is and what a segment is. And what I mean when I ask for those things, even if I don't provide a picture, you should know what I mean by a segment. Okay. Because all the formulas are terrible looking if they're in degrees. All right. Try these problems here. I would rate the first one as easy. Not like if you struggle with it, not to belittle you, but I would count the first one as easy, and the second one as maybe not as easy, right? Even though they both look fairly tame. They look on the face pretty easy, but the second one's a little bit tricky, maybe. So what are we doing? Find the area of a sector here, okay? I even gave you theta in radians. That was nice of you. So really, there's nothing to say here, right? It's just area equals, what is the area of a sector is 1/2 r squared theta. Yay. So is that 25 pi over 18 inches squared? We'll just leave it as an exact answer. That'd be one way to do it, right? Okay, and then what about this? Find the area of a segment. All right, so we've got some circle here. Six, 8, all centimeters. And I'd like to find the area of
the space.
Yeah, by segment, remember we mean
I got you.
that region right there. Okay, is it clear in our minds what we're trying to do? And like I said, the information is very clear. The picture is very clear. But it's a little bit tricky to go and use the formula necessarily because what do we not have in our possession that would be really nice to have? Theta, right? We have r, we're good with that. We'd love to know what theta is, and at this point, we don't know it.
So should we solve for theta first?
So maybe we should figure out what theta is using prior knowledge, from yesterday. Right? See if we can do it. What would it be? How do you compute it? Yeah, we've got side situation. We can figure out what theta is. Not a problem. It's the inverse cosine of some stuff. How about 8 squared minus, can you solve this in your head? I don't know, 6 squared minus 6 squared over Right? So theta will be approximately something. I don't know what. R is 6 centimeters. And then we'll plug both of those in once we do that. We'll plug those into our area formula. You might want to store the value that you get for theta. Oh yeah, it depends whether you use cosine inverse in your calculator in radians or you need it to be in theta. Eventually needs to be in radians.
So should we change it to radians?
So you can do whatever you like, as long as you're being careful. Okay. You might just do it in radians now. Yeah, I don't know. So let's see here. Cosine inverse of 8 squared minus 6 squared minus 6 squared divided by -2. Store in A. How about? All right. Except wait, I wanted that in radians. Wait. All right, so I get 1.46 radians approximately. You can write that down if you like, but what I want is that stored. I stored it in A on my calculator, or whatever letter you like. You can store it. Yeah, if you're gonna go and use it, don't use the full value, right? Okay. So I'll write this down, but just be careful. 1.46 approximately. But I'll write it on here. Stored value.
Richard Montgomery High School. Please pardon the interruption. It was on this day at 11 a.m. in 1918 that World War I ended. The 11th hour, the 11th day of the 11th month. Armistice Day, as it was called, is now celebrated in the United States as Veterans Day. In our democracy, we are so lucky to have had so few been called to protect so many. Please join me in honoring all those who have served this nation. Thank you.
How are we supposed to honor moments? Is he gonna come back up? I don't know. Forever. Okay.
Okay, I got a negative area.
All right, I'm ready to do this here. So I get 18 times minus sine of. Make sure your calculator's in radian mode. Did you get 8.38? That seems.
What?
Theta minus sine theta. My calculator's in radian.
Does not work.
I can't see.
Oh wait.
8.38.
Okay, never mind.
Right, I just typed that in. Careful, make sure it's in.
It's gotta be in radian mode.
All right. We actually finished it. I didn't go over the homework. That's why. All right. Have a. I need to pass you a worksheet here, so stand by.